We're back from break. It is week 2, day 4, part 2. 242. We could reduce that down to 121 if we wanted to. It's the same thing. Nope, we're not going to do that though. So before the break, I had mentioned that we were going to talk about collection classes and we were going to talk about operator overloading. I think the emphasis on collection classes so that it works for this weekend's homework is going to be very important. And to show that we can make a class, we can have it work with collaborate. We can have them collaborate with many of them or with many other classes. So we've already kind of worked with a collection class, but not really as a collection class. And so yesterday, we used a bike. We had a bike that was not a collection class, and we had a race, which contained a collection of bikes. That's really all there is to it. Is that if you have a single thing, be like maybe a class that is like a mouse. Right? I have a class that is a mouse, like an input device for a computer. And I wanted to make a class that represented a collection of mice or mouses, and call it like maybe box of mouses, box of mice. Um, then what we would do is we would pass in, or we could create a number of mice for that collection class. So let's take a look at what that looks like, and then we'll kind of see the value of that. So I'm gonna, in my week 2 directory, I'm going to create a new file, and we're going to call this day_4 collections.py. And with my collections class, I'm going to create 2 classes right here in the file. What is something that can be part of a collection, like a logical collection? Let's do puppies. Everybody loves puppies, right? Because you can have puppies and you can have a litter. Let's do that. So let's make a class. That's a puppy. And that puppy in its init is only going to define its name for now. So we're going to say self.name is equal to, and we're going to pass in the name. Well, let's not pass in the name. We could, but let's give it a default as well. So let's say name is going to be equal to Fido. So we say name is equal to name. This way, if we pass in a name, great. If we don't, it uses name Fido. Let's import random. So I want to do this so that it has a better way of like we can identify an individual dog in here. And I'm going to say that its self.chip is going to be equal to random.randint, let's say 1,000. Now that's going to signify like that chip identification number. It's just a random number between 0 and 999. And we're going to do that so that we can look at all of the dogs in our collection class. So we can say all of the puppies, if you will. All right, and the puppies aren't going to do much. Maybe they can bark, right? Maybe they can say like def, bark, bard. And that's just going to print woof. That's all a puppy really can do, is it can be born, it can be given a name, a chip ID, and it can bark. I'm sure you can come up with many other things that a puppy can do, but we're not going to explore all of those. Now what I want to do is I want to create a collection of puppies, which couldn't be better than anything like ever. So what I'm going to do is make a class, and this is going to be called a litter. And a litter is going to represent a group of puppies. I'm going to say that it's def_init. It's going to take self. And let's kind of explore what we need to do so that the litter can have puppies. So how do you think in our universe a litter should have puppies created? Should we create puppies and then give them to the litter, or should the litter create the puppies itself? What do you think from a design standpoint? So when I create a new litter, it should have its own puppies as a part of it, right? Fair enough, because that is a strong association. That's not just that's not a loose relationship where Maybe a puppy could be part of another litter. No, they can't, because that would be the benefit of making it so that maybe we pass in a puppy, like we can add a puppy to the litter. Like maybe even we can, like if you want to adopt a puppy and add it in or something. Um, not adopt in, not adopt out. That would be getting rid of a puppy, which we're going to do eventually as well. So what we're going to do is I'm going to initially create a number of puppies, a random number of puppies. So let's create a self dot, let's say our self dot puppies is going to be equal to, well, let's start it off as an empty list. Because what I'm going to do is I'm going to loop through, and I'm just going to create a bunch of puppies, and I'm going to append them to self.puppies. Because self.puppies is an empty list. Wow, that was weird. So I'm going to say for underscore in range, and let's do a random number here. Let's say random.rand int, let's say 5. I think that's a relatively good sized litter. And I'm just going to say self.puppies.append in new puppy, open and close. So this class is a collection class, not because of any Python syntax. I want to be absolutely clear about that. At 1038, I make this really good point, that a collection class is not like a built-in Python thing, that we can just say, oh yeah, this is a collection class, now act this certain way. There are some things that we can kind of be clever about, but we're not going to cover those today. But we've made this a collection class because we've designed it that way, that we're going to treat it like a collection class, and we're going to implement features of it that allow it to be a collection class. There are other programming languages that have built-in collection classes that you can just say, hey, this is a collection class, and it automatically does a ton of stuff for you. We're not going to be doing that. We are designing this to do a certain thing and act a certain way. So what I want to do is I want to take a look at all of the puppies that were created in a litter. Like, let's have it like list off their name and their chip ID. Well, their name's all going to be Fido. So let's override our dunder stir, and let's just loop over our litter. Let's say for puppy and self.puppies. I want to print off the puppy.chip ID. And then we're going to return an empty string to stir. This way I can create a litter at the bottom of my program, which I'm doing right here. And I'm going to print the litter. I guess I could have also just printed the puppies, but this will allow me to see all of the puppies inside of my litter. So if I say Python day for collections, what did I break? Oh, rand int needs a range. So we need to change that from 5 to 0 to 5, and then up here 0 to 1,000. Sorry about that. Could have just assumed that 0 was the default. It created 3 puppies, and these were their chip IDs. It created 3 more puppies.
I ran it once and didn't create any puppies.
You are a monster.
We might want to change that random int from 0 to 1 or something. 1 to 7.
Yeah, you guess you can't have a litter. Let's do 1 to 6. You can't really have a litter with 0 puppies. There we go. What error are you getting?
Dunderster return non-string type.
Did you return an empty string? I'm not saying you're wrong. Here, let me come on over there. Oh, you're returning inside of the for loop?
Oh. All right.
Indents. Indents will get you. Okay, so that's cool. I mean, the collection class allows us to create a certain amount of puppies, and we can see those puppies in there. But the really important thing that we want to do is we want to be able to manipulate the collection. So this has a direct effect on your blackjack game this weekend. Is that I'm just gonna like tell you some of the structure. Is that your hand, like the card, will be a collection of the cards you have in hand. Your deck will be a collection of the 52 cards that you have in your deck. Did I mention that this is a hard assignment? Okay, just making sure I've said that before. So we have this collection class here. Oh, and so back to the homework though. You have the collection classes that are your hand, you have your deck. Now, what kind of helpful things would your hand be able to do with the cards it has in it? Yeah, add up the value in the hand. So that could be a method on your hand class, right? Because if you have a collection of cards on the hand class, you could do some math to say, hey, I have an ace and a 2. Awesome. That's, what, 13? So I have a 13 value. Do I hit or do I stay? I want to report that to the person. And so on and so forth. But with our litter here, we don't really have that kind of functionality. You know, like, maybe what we could do, though, is we could adopt a dog. Like, as you have a litter and someone wants to adopt it, we want to remove that dog from our collection. So let's do that. Let's say that we want to adopt a dog by the ID, by their chip ID. This is going to be a little complex, but I think this came up in one of your homework assignments this week. Is essentially what I'm going to do is I'm going to find a puppy in the list of puppies by their chip ID and remove them from the list. So I'm going to make a method here called adopt. Well, first off, I'm going to get some user input. I'm going to say chip underscore ID is going to equal to input and say adopt which dog. I'm going to make a method here called adopt. That's going to take self and chip ID. Because I'm going to pass this chip ID into the adopt method. I have to do that. I can't just set this as a global and expect adopt to get there, to get it from global. That's not only a bad practice, it would be difficult for us to debug when things start going wrong. So it's a lot easier for us as developers to sort of track this chip ID being an input here, and then I just pass that into adopt, and from there I don't have to worry about it being anywhere else or manipulated by anybody else.
What if you may have just answered this
Maybe.
You have the input and the method itself?
You could, but I'm not going to, because that's defining the user interface inside of the collection class. I try to keep the user interface separate from the collection classes or even the data classes. You could even have a class specifically for the user interface. That you have a method called adopt prompt. And adopt prompt could ask the user for their stuff. If they give you back a correct value, then you can call the adopt on a litter. So, because all that is possible. But I try not to, like when I have something like this that just represents the object, the adopt method is going to literally just take a dog out and give it to somebody. It's not going to handle the whole, hey, do you want a dog kind of thing. Okay, so what I'm going to do is I'm going to try to do this in a very basic way. Is I'm going to loop through all of my puppies and see if the chip IDs match. And if they match, I want to remove that dog from the list. Okay? All right, let's do that. So let's say I want to do a for loop for puppy in self.puppies. I want to do a comparison here. I want to see if puppy.chip is double equal to chip ID. I want to remove that puppy from this loop, or from this list. How do you do that? How do you remove a particular, a complex object from a list? You can pop, but we don't know where we're popping from. Because if you pop with no arguments,
You can't say pop puppy, right? Because that would be an index.
what kind of a monster are you? Pop puppy? Goodness gracious. Well, let's take a look at the pop documentation, actually. Remove the item at a given position in the list. So we could pop the... I'm not...
Well, so that's based on index, though. So it looks like dot remove would actually remove it based on the value. So we would probably want to self.puppies dot remove puppy.
Okay, so it's a self.puppies dot remove puppy. What's that?
Plus, then we don't sound like the monster.
We're not going to pop the puppy. That sounds like a really, really terrible video game that you could download for the iPad. Okay, let's see if that works. And another important part is that how do I give this puppy to the little girl that's asking for it?
Return. So we need to return self.puppies dot remove puppy.
What will that do? Let's go explore in Python what that does. So if I say x is equal to a list of one, or a string of one, a value of one, a string of o, and that's good, right? So if I say x dot remove the number 1, and I want to assign that to a value of L, what is the value of L going to be? Is it going to be that 1? L is equal to none. So remove does not return the item of value that you've passed to it. Okay, well, let's take a look at our list now, though, has had that 1 removed from it. So what happened to the 1? It just disappeared. We busted a cap in that puppy. Things my instructor says. The good news is, though, the Python developers, they knew what they were doing. They knew that, well, they assumed that people who used remove were going to be smart programmers. So x.remove, what do you pass into x.remove to get it to remove? The value. What were we trying to return? The value. Seems kind of silly to not just return the value that we have right here in this variable right here. So we are going to remove the puppy, and we are going to return puppy. Now the reason that pop will return the value is because you aren't providing the value to pop. You're providing the index. So it's making an assumption that you don't know what the value is at that location. But if you remove by value, then that will work. But this is a complex object. Will that work? This is a complex, like it's an instance of a class. So when it looks by value, what is it going to look for? We might have to do some operator overloading for this to work. But let's see. That may just be all my experience in .NET talking. Let's see if this works. So after we adopt the dog, I want to say litter.adopt. We're going to pass in the chip ID. Let's say that that's the dog that I just adopted. I want to print the dog, and then I want to print the litter. I'm going to put like a little ASCII art thing so it separates them. So our program will run like this. It's going to create a random litter of dogs. It's going to show us all their chip IDs. We're going to type in one of those chip IDs. Our program will then remove that dog by chip ID from the litter. It will return it. We'll set it to this variable called dog. We'll print out which dog that is. Then we will print a ASCII art line, and then we'll print all the litter.
Do we want to set the stir or rubber of the dog or puppy?
Not right now. I just want to make sure that this returns a dog and not like none or an error or something. So let's see if it works. I'm actually not sure if it'll work. Let's see. Okay, we only have one dog to adopt. This should be easy to test. We're going to adopt dog 136. Didn't adopt the dog. I'm going to give you guys 60 seconds to think of what went wrong here. So it could be anything, but I think I know what it is. What is the type that all inputs come in as? Strings. And what is the type of our chip? Integer. So let's convert our chip ID to integer when we compare it. Let's run our program again. Okay, we have a couple of dogs to pick from. Oh, I'm gonna get the runt. Look at the runt here, number 11. I have a soft spot for the runt of the litter. So let's print this. Let's get this dog. We have this puppy, and that puppy has been removed from the litter, never to be seen again. Cool. So I want to make a method that allows us to add a dog back, maybe return a dog to a litter. Or maybe we can say, we have a dog, we want to add this dog to the litter because it didn't have a home, and now it's got a bunch of brothers and sisters. So I want to add a method into my litter to do that, to say that a dog can be adopted and a dog can be added to the litter. That's gonna.
Random question.
Yeah.
Is there a reason why you were adding the method above the stir instead of just adding after?
I try to keep the stir at the very bottom, but that's just habit. The order of these does not matter. I try to keep init at the top. It doesn't have to be. I try to keep all of the class members above the init. They don't have to be. And I try to keep all of the instance methods above the stir and the repr. I try to do all of the overloaded compare. What is the other one? The add, greater than, those kinds of things. I try to keep those at the bottom.
So you do init your methods, the operator overloads, and then stir.
Stir is an operator overload. But yeah.
Right.
All right. So what I want to do is I want to implement a method on litter that will add a dog to the litter. But I don't want it to add a dog that's already in the litter. Like, what if I make a dog with the same chip ID? That might be the same. Or essentially, I could in my program, I could potentially create a dog with a name and a same chip ID and then add it to the litter, and then that would break everything, because then when somebody tried to adopt it, chip ID would be the same, and some poor dog wouldn't get to go home because another dog got adopted before it. Can't decide if this is being too convoluted or not. It matches what you're going to be doing with your weekend homework assignment, though, because you're going to have to add a card to your hand. When you're playing blackjack and you have a hit, you want to say, I want to take a card from the deck. I want to remove it, just the top one. Doesn't need to be from, maybe the bottom of the deck if you really know what you're doing. But you can just take it off the top, move it from the deck, and move it into your hand. Now that's class collaboration right there, because you might have a couple of different things. I think we should just do that. Like, if I just gave that to you, would that be useful? Maybe we could do like a small iteration of that. Because the puppies thing, we're just forcing it. I feel like the whole, we need to add a dog to the litter. I think we're just forcing it at that point. So what I want to do is I want to create like a card, a hand, and a deck. And I'm not going to implement all the methods. But what I'm going to do is I'm going to implement the methods that allows you to take a card from the deck and move it into the hand. That's all I'll do. So I think that's typically a pain point for students on this assignment. And once you get over that, it's kind of like smooth sailing. It's not really, and it doesn't need to be a pain point because that's such a small thing, but it's so new. So let's make a new file in week 2. Let's call it day_4. Let's call it cards. Let's code the game of war. Do you remember the game of war?
Yes.
The game of war is when 2 players get a card. Whichever card is higher, that player wins that round. We're not going to do the whole like keep a stack. We're just going to say, hey, if you have a higher card, you win. If you have a lower card, you lose. This will take us the whole hour. It will include collection classes, operator overloading, and game state. I can't think of a better example to lead into blackjack. Oh, Joel, you're so smart. Okay. Before we start with the game of war, though, as you'll see in a lot of my programs that we start, and make a note, at 10:59, the lecture really gets good. So that when Kevin's watching this later, he's not just like, where's he going with this puppy thing? Like, we can just go right to 10:59 and not waste the time like you all had to. Or somebody just send him a message now and say, hey, when the lecture starts, just skip to that time. Okay, so I want to create the game of war. The card game of war, folks. The rules are that, let's list out the actors. There's a deck. There's a player 1. There's a player 2. There's rules. The rules are player 1 card greater than player 2 card equals player 1 win, or warning. Player 1 win. Player 1 card is equal to player 2 card equals tie. That's really our only rule. Now, of course, these rules they go back and forth. If player 2's card is greater than player 1's card, it wins. Player 1 card, you know what I mean. Wow, I'm actually going to give you a lot of the assignment right today with this. Oh well, maybe this will make it so it's a little bit more hand-holdy, but I'm gonna go with it. So I'm gonna start off with my first actor, which is my card. Oh yeah, I also need a card. Because the card and the deck thing is important. And I'm gonna not give you everything because I don't want you to copy and paste this into your program this weekend. So we're gonna have a greatly reduced game of war. Like, we're only gonna have one suit of cards, and the cards are gonna be from like 1 to 6. You'll have to figure out the rest. So if I have a class called a card, Actually, we don't even need a suit. Let's not do a suit. We're just going to do a value. Because the suit is giving away way too much. In that card's init, I want to pass in its value. I want to create it with a value, and that self value is equal to value. By the way, this is it for the card class, for now. Because we're eventually going to want to compare these cards, right? Player 1 card is greater than player 2 card. So we're going to have to do some of these. We're going to have to overload some of these so that we can say that when you have two customized objects, two complex objects, you can't just say object 1 is greater than object 2. You have to have it compared to an underlying value somewhere. And I'll show you how to do that.
So you could technically, like if you want to compare cards without doing the operator overload, you could just do card.value.
Yes.
compared to-
You could just do that. But why would you want to do that? All right. Now I'm going to create a deck of cards. This deck of cards will not have 52 cards in it. This deck of cards will have 25 cards in it. And this is going to be an init. This is going to be an interesting game because I'm totally changing it. I'm making this completely different. What I'm going to do is I'm going to make 5 groups of 5 cards. So basically this game will be the cards 1 through 5, 5 times. I want to make it different enough so you can't just copy and paste this into your homework assignment. So let's do that. So the deck is going to consist of cards value 1 through 5, 5 times. So there's going to be 5 1s, 5 2s, 5 3s, and 5 4s, and 5 5s. So let's explore how we would do that. How would you do that? If I wanted to first off, let me pass here. How would I create a card down here? That's a very basic, not trick question.
Card equals capital C card.
Card is equal to capital C card. We need one more piece
you
of.
can pass it value.
We need to pass a value. Okay. So right here, let's start off with a value of 1. How would I create a card with a value of 2? And so on and so forth until I have 25 cards being created. This sucks though. You know, they say invention is the mother of all, or necessity is the mother of all invention, right? What is my necessity here?
Well, but you need, 5 cards of each value.
5 times. So instead of freaking doing this and typing it all out manually, how can I do this in a more clever, not clever, lazy way? A for loop, did you say? So just nod. Yep, I did say that. I said a for loop. I'm sure you did say a for loop. So what I want to do is I want to say for value in a range of 1 to 6. Because remember, we don't want to pass a 0. That would be a dumb card. That would be like the Joker. Ooh, that would be cool if a 0 beat all cards. Maybe we can add that into the rules later, where a 1 just beats all. 1s are wild. So what do I want to do in this for value 1 through 6? Do I just create a card like this? Like, do I just copy these 5 lines? Call it a day? Because this will create 5 cards 5 times.
The one you need to store those someplace.
Okay, where do I need to store them?
Probably a list.
A list. Let's say, so our self dot, maybe we could say our cards is equal to an empty list. And here I can say self.cards.append this card here. And maybe I could just 1, 2, 3, 4, 5. All right, we're getting less lazy now. What is a even less lazier way of doing this? Like we're building iteratively here. Step 1, step 2, step 3. What are these values here?
You could do another for loop.
I could do another for loop, absolutely. This for loop we're just going to throw away. Or no, for other value in range 1 to 6. Okay, so am I done now? How many cards will this put into my deck?
Well, you don't need all that. You just do self.card.
Exactly, I just need 1 now. All right, am I done? I'm impatient now.
Self.cards.
Self-deck, oh yeah, sorry about that. Self-deck cards, am I done?
No, it needs to be card, other value.
Why not value?
Because value is how many times you're creating that list of 5 cards. The other is the one where you're actually cycling through the values. So instead of having to type out the pin 5 times, you have the for loop doing it for you.
Well, let's take a look. Let's say out loud real quick, and I'm going to write this down. If I set this to value, what will the value? Don't worry about the cards. What will the value, like as this goes and appends through there? How will the numbers be structured?
I see. Okay, so what if you do it by value? It's going to create 5 1s, 5 2s, and
Yep.
they're going to be next to each other.
Yep. It's going to just be 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. Whereas if we went with other value, how will that change how the cards are structured? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Either way, doesn't matter. We're going to shuffle these cards up. We need to shuffle them. But we have a deck now, right? That's good. Let's override our Dunder Stir on our deck so we can take a look at how the values are structured in cards. This is going to be the same as the puppy litter. So I'm going to say I want a for card of self.cards. I want to print the card.value and then return an empty string. By the way, make sure your return is not inside of the for loop. So now when I make a deck, let's say that my deck is going to be equal to an open and closed deck. I want to print the deck. And let's take a look at how changing that from other value to value, let's see if I was right or if I was wrong. Let's change that to Python day 4 cards. Uh-oh. For card of, what language am I writing? For card of self.cards. Did either of you write for card of self.cards?
I did.
Gotta break that habit.
Caught it before I ran it,
You caught it before you ran it? It's alright. That's a different thing. Okay, so these are our cards, how they're structured in our deck. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the debug information that we need. So it might seem funny that I'm going through all of these steps, but these steps are necessary for you as a developer. Like, they're not necessary for the completion of the program. You could go the entire writing of the program, beginning to end, turn it in Monday morning, it works great. You could go through that without doing any of this. But it's a habit that you're going to want to get into, of how can I make sure what I'm doing is doing the right thing. And usually overriding a Dunder Stir to show you all of the underlying data is the #1 way to find out of what's gone wrong. Because watch what happens. Like, you don't have to follow along with this, but if I just change this to value, look how that small, inconspicuous change has changed the structure of my deck. No, before, all the cards are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, they are grouped. 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. And plus, when you're playing a game that will take the top card off the deck and compare it, you're going to have a draw pretty much 1/5 or most of the time. And then when you don't have a draw, the same person's going to win every time. Not a very fun game. So what we want to do is we need to shuffle. We need to shuffle the deck. Oh, crap. That means a lot of work, right? We're going to need to move indexes all around, all over the place. Well, fortunately, you all decided to take the Python class. And there is a method called random.shuffle. And it will shuffle the sequence in place. Okay, let's slow down.
It says my net under deck takes one position argument, but two were given.
What does your method signature for a init look like? Just self, right?
Yeah, just
And then down here, how are you creating the deck? What are you passing into there?
it's exactly like you have it there.
Yeah? What about the card?
I've got other value in there.
That's fine. And now when you go up and look at your card, what does the card's init look like?
I don't have value.
Yeah.
Power.
There it goes. Yeah. So whenever you see the whole off by 1, hey, I have this method, but it expected 2, but you passed 3, that means that there's an argument parameter mismatch. That you have 2 here or 1 here, and you're passing in 1 value here. Okay. So we're going to use random.shuffle to shuffle up my cards. Now, the reason why this output is so important is because now we see that they're all ordered. But when I go into my editor, and now this is not inside of the for loop, I'm gonna call random.shuffle, and I'm gonna pass self.cards into random.shuffle. This is in the dunder init, outside of the for loop. If you did it inside the for loop, it's just gonna shuffle it up every time you add a new card to it. When we run it, oh, I didn't import random? What kind of a monster am I? Now look at our cards. So I do want to point something out. This will totally screw you up on this homework if we don't point this out. Why do you think switching value and other value worked perfectly? Why do you think that was allowable in my program? What's the feature? What do value and other value have in common? They're integers, correct? I'm looking for something a little bit more specific about what kind of data, like what is the shape of the data structure? If you were to draw out height and width of all the cards laid out on a table, what shape would it be? Would it be a triangle? Would it be a cube? Would it be a square?
You're talking about
Like if you were to take 25 cards and you were to lay them all out 5 by 5, what shape would it be? A square. That's why I was able to flip them, and have the inverse be true as well. That will not work for your assignment this weekend because how many suits are there in blackjack?
you even have to worry about the suit.
Yes. Well, your deck will. And it has nothing to do with the game, but for your output, because a card has to be unique, right? So you need a 3 of clubs is not the same as a 3 of hearts. I guess in your calculation you wouldn't have to worry about it, but the user wants to know, especially if they're playing a bunch of games over and over again with the same deck, and they know that the 3 of clubs has already been played, they'd be able to track that in their head a little bit better to know.
Shuffle after each game.
You will shuffle after each game, but you wouldn't add new cards to the deck. Like, that's the extra hard mode, I think, is to work with a boot that has like 5 decks. But over the course of a game, if the deck runs out of cards, you can have a new deck. But over the course of playing multiple games, you can choose to use the same deck so that you can practice your card counting abilities. That's up to you, though. That's a small feature of the program that I think could add a lot of awesomeness to it. Anyways, but the only reason that this works is because the height and width are the same. So if I have four suits of, was it 13 cards or 12 cards? 10,
Yeah.
13 cards. I think whatever it is, that's not square. That gives you 52 cards, whatever it is. So that means that one of these is going to have to be 4 and the other one's going to have to be 12. So just keep that in mind. So if I was to change other value to be 10, that would mean that I have 5 groups of 1 to 10 cards. Give me 50 cards. I'm going to leave it at 1 to 5 though. But look at my deck now. It's shuffled up. And I can tweak this parameter, so we're going to set that to other value. They're shuffled up anyway. It doesn't really matter. Okay, let's build the game now. Let's build the game. And the process that I'm going through right now is 1,000 times more important to you as a student than the code that I'm writing. Because when you when you have to work on this by yourself tonight or in lab and you want to take a stab at it, the first thing you're going to hit is, what is my process? And I'm going to say, what did we do in class? Because that's always going to be the most important thing. Like, what is the first step? Well, you can mirror my process. You guys know how much I hate plagiarism. You can plagiarize my process to the word that you say in your head, and you won't get knocked any points. The code, though, however, you can't just copy and paste. So the next part here that we go through is very important, starting at 11:18. My thought process is very important, and how I take the steps from, okay, I have a deck, now how am I going to play through this game, and what are going to be the steps to play through this game are very important. So I think that over the remainder of the hour, I'll give you the code at the end of the day. The important thing is going to be my decision making, is the important part of this lecture. So I'm going to drill that home enough. So let's get started. The video game logic that we have 2 players. Each player is going to be given a card. We need to say, who has the higher card. Whoever has the higher card gets the point. That's our whole game. That's the whole video game. So the first thing I said is we have 2 players. So we need 2 players somehow. We could represent 2 players as we did earlier in a collection. We can hard code it in. Like, we can go iteratively if we want. We can go copy and paste some code here. Whoops. You guys you see that picture? Please kill me now. I don't think I sent this to you. I sent it to Kevin and Zach. I was going to send it to you later. I was on my way back, but yeah. Please kill me now. I sent it to my buddy Alex, and I was like, when one Gibson headstock isn't enough for your guitar.
Well, you wouldn't need the other one.
All right. Okay, so we're going to start off this big one here. I'm going to do all of the logic for the first part, and then all the logic for the second part. So that at the very bottom, I can say, what do both of these cards have? So I have a deck. I only need one deck here. I'm going to start off with my Wild True. Because what I want to do is my next step here, remember the most important part in the rest of this is my process. My most important thing that I want to know is that each player can have a card from the deck. Okay? That's it. And I'm not going to overcomplicate this. You may watch this process and think, why is he doing this in this way? This is so simple. It's because I like simple. Simple is a great way to express your initial idea, and then you can go in and you can go back and make it object-oriented, but if it works, awesome. And then you can build on top of that. So that's what I'm going to do is I'm going to make it work first, and then I'm going to build on top of it. And what I'm going to do is my player 1, I'm going to give player 1 a card from my deck. So how do you remove one item from a list? Remove? No. Well, we don't know which one we want to remove. We just want the top one, right? Right. So let's make a method on our deck here. I'm going to call this method draw. And what draw is going to do is it's just going to return self.cards.pop. Now that will work because pop is a method on cards, which takes the card that's on, or that's the item that's on the very top of the list, removes it from the list, and then it returns it. And so this allows us, when we return that return, it allows us to set player_1 equal to deck.draw. So now player 1 has a card. Actually, player 1 is a card, which is weird, but when you think about it, from the perspective of the game, you don't need to know about that much about a player. You don't need to know their thoughts and their feelings, how tall they are, or what their name is. Player 1 is a card. And you should think of player 1 as a card in your blackjack game. Or a hand, not a card. It's multiple cards. But in our case, it's just one card. Okay, so if that's how I draw for player 1, how do I draw for player 2? Same way. Player 2 is equal to deck.draw. So I've got two cards from the deck. I just need to compare them. So maybe we could say, well, how do I declare the winner on the comparison? Whoever's bigger. How would you tell that?
Player 1 greater than player 2. Player 1's the winner.
Okay, so let's make a variable called player1 winner is equal to player_1. Now I need to do dot value, right? Dot value is greater than player2 dot value. Okay, now what? I have a variable that says if player 1 is the winner. So I could say if player 1 winner, print player 1 was the winner. Should I output what the cards are, though? Like who has which card? Let's do that. Let's say above player 1 winner, I'm just going to put a couple of silly prints here. I'm going to say player 1, and let's make sure that that's an F string. Let's say player_1 dot value. Player 2, player 2. I'll give you a second to catch up on that. So player 1 print will show you the value of the player 1's card. This player 2 print will show you the value of the player 2 card. Player 1 will win. And we're going to say if player 1 is the winner, player 1 was the winner. What if player 1 wasn't the winner? What should I do? Because if player 2 has a higher card, player 1 winner will be a false Boolean. I gotta check if they're equal. Okay. So if I say elif what if we say like tie? Say player_1 dot value is double equal to player_2 dot value. If I say elif tie, what do I want to say here? I can just do another print, right? It was a tie. And what's the last case here? If player 1 was a winner, or if it was a tie, what would be the third case that would possibly happen?
Player 2.
Right, let's throw that into our else. I'm going to say print player 2 was the winner. Notice, like, again, I need to reiterate, we're focusing on my process, not the if, else, and comparisons going on here. Like, that is some day one looking stuff right there. I'm fine with that. I don't want you to overcomplicate anything, especially if it helps you understand what's going on. If this is the solution you came to because you understood it after a lot of trial and error and it works, great. I just don't want you to turn something in that you don't understand. Okay, let's run this and see if it, well, actually, let's put an input up here so it just doesn't run a million miles an hour. So we're going to run it, we have to hit enter, and then it's going to play the game, and then we're just going to hit enter, and it's going to continue to play the game. We run day 4 cards. Okay, so it shows all the cards. We actually know who's going to win just by looking at those cards. And if I hit enter, it was a tie. Well, look, we can see these 2 cards here at the very bottom are 4 and 4. So it drew those 2 cards, and it was a tie. So who do you think is going to win next turn? Player 2? Well, player 1's going to draw first. Player 1 was the winner. So who's going to be the winner again? Player 1. Who's going to be the winner again? They're on a roll here. Then after that, though, player 2 is going to win. 1 and 2. So this is a very basic game. It appears random. Player 1 wins, player 2 wins, player 1 wins, player 2. We would expect with an evenly distributed deck that was randomly shuffled using a uniform distribution, and we're just picking off the top and then picking off the next, we would expect a 50% win rate here between players, right? Or at least like a 49.9% win rate for one player over the other, just accounting for some like atmospheric pressure or, you know, sun rays or something like that hitting your computer. That's not really a thing, by the way.
Actually, there was a lady that worked for a client of ours that actually thought sunlight makes your computer slow.
So the interesting thing about that is that they might be, well, about it being slower, I guess like sun's radiation could warm your computer up, which causes a slowdown because when your computer runs hot, I guess, it tends to get slow. But no, the idea that radiation and atmospheric interference could mess with the random number generator of your computer is not true. But it would actually be really good if it could, because the random number generator that's in your computer, here's a little computer science. So at 11:29, I start going off on a side note here, is that the random number generator in your computer is not true random. It's just sort of picking a random number based off of as much entropy as your computer can create. But ultimately, it's working within a fixed sample space. And that means that it's not true random. And so there are attempts, and in fact, I don't think there's ever been a successful true random. But there's been close. But what people have attempted to do with true random is to use, because you need a random seed. Right? And the thing is that if you're just picking a random seed of a number between like 0 and 1 million, right? Like, okay, then you have a sample space of 0 and 1 million. But if you picked a sample, if you picked a seed from a truly random source, then your number that you generate from that seed would match how random that seed was. So what people have done is things like they record audio from the computer, from the microphone, and they use the audio signals that are coming from the space, background noise, people talking, to act as a seed, and they pick magnitudes and wavelengths from there to say that's going to be my random number. Well, if you're doing that, things like electromagnetic interference could affect the random seed generator, especially if it was picking up something audible. You know, anybody who's ever plugged in an amp knows that if there's electromagnetic interference going into whatever's being received, it will interfere and cause a buzz or something like that. So we could see a future where our random number generators are picking from something atmospheric for random generation, and we might be able to manipulate those. You could see a superhero like blasting electromagnetic pulses at computers to make it more predictable, right? So science fiction, baby. Okay, let's get this back on track at 11:32. I want to make this a little bit more meaty. I want to make this more like a game because this is really contrived. This is actually a really good demo because it demos really well. But I want to take it a step further. I want to make it so that a player doesn't just draw one card. I want to make it so that a player draws 2 cards. Know what I'm saying? Then what we do is we compare those 2 cards for that player, and whoever has the highest value of those 2 cards wins the round. So it's not technically war anymore, but it is a basic card game. The game's going to go faster, but it's more complex now. If we tried to wedge that into here, our program would grow crazy. So now we need to think about this in more of an object-oriented approach. We need to think, okay, if I have a player needs to have a hand, and it needs to get cards into its hand. And then it needs to tell me the value of its hand so that I can compare that to the other player. So let's start in doing that. And we already have a lot of the core functionality of what's going on inside the game here, but we don't have this idea that a player can have 2 cards. Just 1 card. In fact, that card is just a single card. Let's extend this, though. I'm going to add another class here. And I'm going to name this class Player. This will also allow us to easily extend it so that we can add as many players to this game if we want, eventually. So inside of this player, I'm going to need to store 2 cards. We've done something similar to that before, like with the litter and the puppies. We create 2 cards. So let's create an init. And I'm not going to give it initially any cards. I am going to just create self.hand is equal to an empty list. So this self.hand is going to be given cards from the game. I have a card class. I have a deck class. The card class is like the leaf node. It just has the value. The deck class has all of the cards that we draw from. The player class is going to be the logic that says, okay, I am one of the actors of this game. And then all this code down here, this is going to be my game. So this is the program. This is the program actor, which is not a class right now. It doesn't need to be a class right now because all of the functionality is all grouped down here. And eventually we could make it a game. We could call it like a game controller. We'll see if we have time for that. We probably won't. So if I have a player and a player has a hand, how do I want to add a card to that hand? So if you have a list, how do you add an item to a list? Append. So where would I do, would I do that here in the init? I said that I don't want to create a player with their initial cards. I want to be able to add a card later. So I'm going to make a method here that allows me the ability to push or to append cards onto my hand. So if I have a player, I'm going to make a method called add. I'm going to say self.hand. Oh, that's also going to take a card. Self.hand is going to .append the card. Now let's think of this from a little bit more of a realistic point of view. If it's you and me playing this game, and you draw your own cards, there's no dealer involved, right? You just sit there and you pick 2 cards off the top of the deck. From the perspective of the game, the player has control of the deck, right? I kind of want to draw this out. I don't like to do that when I'm recording lecture because it's hard for people at home to view. Let's see if I can, like, online drawing. Sketchpad. Let's see how this works. If it doesn't work, it's a fail. Calligraphy, I want a pencil. Is there a pencil? Perfect. Okay, that's great. Command-Z even works. Okay, so I'm going to diagram out the actors of what's going on here. Okay, so if I've got a deck of cards, ignore the bad drawing. I'm drawing with my, oh, I have a mouse here. I can just draw with the mouse. I'll do that. So these are my 25 cards. And then I have 2 people here. And they are each going to have 2 cards. From the perspective of the game, like when we want to write this code, should we have the option of doing one of 2 things. We can take 2 cards from the deck and give them individually to a player, like from outside of the player. So this is what it would look like. I'm going to take 2 cards from this deck, and I'm going to hand them, I'm going to pass them in to my draw method. Or, here's the other thing we can do, is I can take this deck, give the deck to the player, allow them to take 2 cards off the top. Which one would you rather do? Because this way we're passing 2 cards to the player. This one we're passing the deck to the player and allowing them to take 2 cards for themselves. Do you think one way is better than the other? That's a yes or no question. It's not a trick.
Not necessarily.
The answer was not necessarily. What do you think, John? Is one way better than the other?
The end result is the same.
The end result is the same. You're learning more about me, is that I look for results. So if you 2 programmers turned in a result that one player did this, or one of your programs did this and the other program did this, you'd both be fine. Okay? This all boils down to preference. Which do you better understand? Do you better understand the ability for a player to be passed 2 cards from a dealer? Or do you better understand that the player is handed the deck and they take 2 cards for themselves and they put the deck back?
Seems like less steps for the deck to give them the cards.
Less steps for the deck for them to give them the cards.
Taking the deck, putting the deck back.
Okay, so let's go ahead, let's code it this way. Let's code it in the way that the deck gets passed to the user, and the user takes 2 cards for themselves. Now we've already coded the ability to take a card from it. Wait, that's the deck. Here we go. But we can add a card to the player's hand. So let's make a new method on the player called draw from deck. And that's going to be handed a deck. So I have a deck here, which means that I have all these methods above that available to me here, because now it is a temporary collaborator, which was referred to as a, starts with a D, rhymes with appendency. A dependency. If it's temporary, it means that it's passed in, the player will use the deck in a temporary way, and then they'll have to get rid of it. So what we want to do is, we want to draw a card from the deck here in this method on the player. Do we have a method to do that on our deck?
self.add, and then in parentheses, deck.draw.
Okay, so John says we need to do self.add, and in parentheses say deck.draw. What do you think of that, Zach? It should work. Which class is self.add on? I'm going to ask some weird questions here. I'm not trying to trick anybody, though. What's that? The player. Which class is draw on? So we are essentially saying these two classes are collaborating. We're using a method from each one. We're saying, I want the deck to draw a card. And then we want to add a card to my hand. So I could have just said self.handoutAppend here. But I was going in a different direction. And I'm going to use that code. That's fine. That's good code. That's good programming practice to me. Okay, my thought process is, what's that?
You can only do that because deck is there, correct?
That's a fantastic question that is perfectly timed. The only reason I can say deck.draw is because this method has a deck getting passed into it. Now, I don't have the code to support this yet, but I know that the way that I'm designing it, my thought process is saying that I'm going to make a method that I can pass a deck to. Now, do I have a deck down here? Yeah, I have a deck. It's right here. I'm drawing cards. And so instead of drawing cards and assigning them to a variable, all I'll wind up doing is making a player saying draw from deck and passing it a deck. So let's actually look at what that looks like. You know what? I'm just going to erase all of this. Gosh, I didn't save that, did I? Oh well, the end result is going to be what we want anyway. The thought process, that's what we pay attention to. So I'm going to erase all of this. We're going to burn it down. I'm going to make a player. So I'm going to say player 1 is equal to a new player. Player 2 is equal to a new player. So if I want to set the hand on that player, I'm going to need to say player 1 is equal to, player 1.draw from deck. And what do I pass in to draw from deck? The deck. Now, will that set 2 cards into my player's hand?
No, because we only have it doing one card.
We only have it calling once. So what do I need to do to make this draw 2 cards?
Have it do the draw, either draw from deck twice or have draw from deck do 2 cards.
I like the second thing that you said there. We need to make draw from deck add 2 drawn cards. So I want to add a drawn card from the deck. Okay? So that means that player 1 has their cards. We're absolutely going to do the same for player 2. So player 1 has 2 cards. Player 2 now has 2 cards. Notice how I abstracted that out of my game and onto the player. When I say abstract, I mean just moved it somewhere else and kind of hid it behind a nice method name. So if I have a player that has 2 cards, now what I need to do is I need to be able to compare these 2 players. I need to be able to say which one of you has the highest value of the cards. So what's my thought process say? Like if I have 2 cards and I need to compare who has the highest value of those cards, from the player's perspective, what work do I need to do now? Like when you're playing this game, what does your brain do to see if you have the higher value cards? I need to add them up. So I'm going to make a method here. Let's say deck value. What's that? Yes, sorry, hand value. We're going to say hand value. And hand value is going to add up all of the cards in our hand. Now I'm going to do this in not a very clever way. But remember, the thought process is the important part. So the way that I'm going to add these up is I'm going to use an accumulator pattern, which we've already seen before. I just didn't use that term for it. This pattern will allow us to say that I have a value locally, not on self, of 0. This local value of 0. Then I am going to for over my self.hand, or sorry, for card in self.hand, and I'm going to add, what is it, the card.value? Yeah, card.value to my local variable value. Now that will go through both the cards and it will say the first card's 3. Okay, so my value is now 3. Go through the next card and it'll say this card's value is 1. And then it will say, okay, so now my total value is 4. And at the very bottom of this, I want to return the value. So we have, like I said, we've already seen this pattern before where we take an initial value, we add to it, and then we do something with it. But so I have a hand value of a player. So does that mean that I can compare player1.hand value and player2.hand value to see who wins or who loses? Let's check it out. Let's say let's do a print of an F string that says player1, and let's interpolate here the player1.hand_value. Make sure that you're calling that method here in the F string. By calling that method, I mean adding the 2 parentheses to it. Now I'm going to do the same thing for player 2. And I'm not going to put the comparison down here. I just want to see which player has the higher count of cards. I'll let this sit here for a while so you all get a chance to get caught up. Okay, so if that's our program, let's just run this and see how it goes. Day 4 cards. Okay, there's our deck. So it looks like player 1 is going to get a 6, and player 2 is going to get a 6. Let's play it. That's correct, right? Awesome. All right, so now player 1 is going to get a 5, and player 2 is going to get an 8. So our program appears to be having cards and adding them up correctly. By the way, your weekend assignment is going to have to do this as well with blackjack. It's going to need to add up constantly the state of the hand with a twist. Aces can be 1 or 11. You also have face cards. Jack, King, Queen, which are all 10. Right? Yes, they're all 10. So you need to show the user that they've drawn a jack. But when you add up the value, you need to count that J as a 10. And you also need to be able to count the A as an 11 or a 1, depending on if they're busted or not. That's the hardest part. After you get past the user interface and the game logic, when you get to the whole, is an ace 11 or is it 1? That's a hard thing to do. So anyways, let's go ahead and round this off. I've got player 1 and player 2 able to have their values. Now what I need to do is I need to be able to declare a winner. And we can do that the exact same way. I could compare those. So I can say player 1 winner is equal to player_1.hand value is greater than player_2.hand value. And then I can do the whole if-else thing. I can say if player 1 winner print player 1 wins, elif, let's do the tie again. This is so annoying. Hand value is double equal to, I'm kind of hitting the gas here because we already typed a lot of this out. So I'm going to say elif tie, and print there was a tie. And we're going to say else, print player 2 1. All right. We're going to get into the operator overloading here next, so don't worry, that's coming. I'm not going to let you all go home without that. We all caught up here? It's okay if you're catching up. You know where it's going. There was a tie. Player 1 wins. Player 1 wins again. Player 1 wins again. There we go. Finally, player 2 won one. Yay, we did it, folks. We made a cool game. And then we made the rules a little bit harder. So let's do one more thing. Let's make it so that comparing players is a heck of a lot easier. So what I want to do is I want to be able to overload a method on the player here, because that's ultimately what we're comparing. We're saying player 1 versus player 2. And we have these two comparisons. We have greater than, and we have equal to, which means that those are the two that we want to overload. So first off, let's overload greater than. So that's going to be def double underscore GT. I have that memorized because GT is greater than, which takes two arguments, or parameters, self and other. And you can name other whatever you want to. You can name it other player if you want. It doesn't matter. And what we're going to do is we're going to say return. We want to return self.handValue is greater than other.handValue. Does that look familiar? Here's a fun thought exercise. What do you think would happen if I just said return self is greater than other? Like this symbol here. What would happen if I just said return self? I think you would get this one over anyone, John. You're the one who loves recursion. It would run infinitely. It would never stop running, because self greater than other would call greater than right here. And it would just keep calling over and over and over again. So what we need to do is we need to say self.handValue, which returns an integer, is greater than other.handValue, which returns an integer. And so that changes our code to look like this. Down here in player 1 winner, we can just say player 1 is greater than player 2. And we can do the same thing with tie. I can change this to say def underscore EQ, self and other, and I want to return self.handValue is double equal to other.handValue. That allows me to change my game code to just say player 1 is double equal to player 2. Much cleaner now. My game logic makes a lot more sense because I've abstracted away up to here in these little helper methods. So I've got a card, I've got a deck, and I've got a player. Let's think of the responsibilities that each one of these actors has. What are the responsibilities of a card? Just to hold a value. It's a very naive card. Like, just as you would a card in a real game of cards. A card doesn't do anything. You can flick it, you can bend it, you can shuffle it, but you're doing everything to it. It can't do anything. It just holds its value and maybe some other information about it. It's how we interpret the rules that makes a card interesting. So we move on. What are the responsibilities of a deck? The responsibilities of this deck is to, what does the init do? Holds a collection of cards, and what else does it do in the init? It creates the cards, and what else does it do in the init? It's dealing them. It doesn't deal them in the init. Assigns a value. What else? What is it? What else does it do in the init? It shuffles it. That's like the best deck of cards ever. It's like you just magically set. You tap on the Like in your universe in this program, you say deck of cards, boom, and it springs to life with 25 cards and they're shuffled. That's what we've done. Like you say, deck of cards, you wave your wand, it pops into your program, perfectly populated. What else can this deck do? It can decide that one card has disappeared and gone off somewhere else. It doesn't know. From the perspective of the deck, that card is gone. It doesn't care who used it. It doesn't care if it fell on the floor. It doesn't care if a person used it in a game. From the perspective of the deck, that card is now gone. Does the deck need to care what happens to it? No. A deck is just sitting there helping us play a game. And a deck can also, you can fan a deck out and it can show you all of the cards that are a part of it. That's all the responsibilities of the deck. Does a deck collaborate with anybody? Does a deck have a dependency or an association to anybody? A permanent relationship?
There's a permanent relationship with cards.
Yes. A deck has many cards. And those cards, while they might be fleeting, we could consider their relationship permanent because a deck is nothing without cards. It's a collection class. So if it was a dependency, that would mean that, okay, a card could come in and then it could go out. It will rely on it, but then it won't rely on it. But in this case, the deck is a hard reliance on the card, which means that it is an association. It has many cards that are associated with it. Without cards, you have no deck.
Would most collection classes have an association?
Yes. It's going to have an association to whichever the item class that it is a collection of will have. Okay, let's look at the player now. Now, the player is one of our primary actors of the program. I think this has gone really well, by the way. Does anybody else agree? Does anybody else, I'm not just trying to pat myself in the back. I think we should probably say, the last 10 minutes I've really shined a light on maybe something that was confusing yesterday on the whole dependency actor thing. Okay, so let's get back to here. What are the responsibilities of the player from this perspective? What does a player's init do? When a player enters the game, what preconceived notions do they have when you sit down at that table?
They're going to have a hand.
Yeah, but they don't have any cards, right? You sit down at a game table. Maybe you have money. I don't know. We're not talking about, we don't do gambling here. We don't want to lose our education license by advocating gambling. Please don't add gambling. But yeah, so self.hand just shows up as empty. What else can the player class do? What are its responsibilities?
It's adding cards to the hand.
It's adding a card to the hand with add. And let's look at draw from deck, because that is no longer... The draw from deck is no longer naively doing something. Draw from deck is a very deliberate action with a dependency. This is going to use a temporary dependency on deck, which is coming in externally. The player was not created with a deck in hand. The deck was given to them. It's never set on their instance. We don't have a self.deck anywhere. It comes in and then it disappears. So we're saying that, go ahead.
So the player class has a dependency on the deck because it's temporary.
Yes, it has,
an association with cards because
it's through its hand.
right.
Yes, that's an interesting way to put it. A player has a more permanent relationship to cards through its hand. But it has a very temporary relationship with deck in order to get the cards into its hand. I don't think I've ever had that better explained in doing this process. So what we're doing is we're taking a card from the deck, because it has its own draw method. We are moving it into our own hand through a method called self.add, all of which we've created. We've created all of these methods except for append and pop. So when you get down to the core of Python, append and pop are really the only things from Python that we're using with these methods. Everything else, we've just been creative in how we've done it. Okay, what else can a player do?
Adds the value of its cards.
Okay, so it has its permanent dependency on its hand, so it's able to look at the cards and say, what is your value? It's able to just do basic math. It's able to see a 5 and a 6 and know that that equals 11. So that is what the hand value does. And then the greater than or equal, that's able for me to look at somebody else's cards and say, my hand value is greater than your hand value, yes or no, true, false. And equal is able to say, my hand value is equal to your value. And that's all it does. Like, the actor does not know what game they're playing. The player does not know what game they're playing. The player just knows that, like, imagine like they just have a blindfold on. They don't know what they're doing. They're in an experiment somewhere in a white padded room. All they know is that they're going to be given cards, or they've been given the instructions to take 2 cards every now and then. And they are told that when they're told, they're going to report the hand value, or they're going to tell if they're going to be given another hand value. Or no, they're going to be given another deck. No, that's not another deck, another player, and they're going to look at their hand value. They don't know what game they're playing, or if they won, or if they lost. That's the responsibility of the game. And here we are in the game. Is the game a class? Right here. No, but it absolutely could be. Should it be? I'm doing the shrug emoji right now. It should be, possibly. If you turned this in, though, and this was your game, I'd be okay with it. If you understood it and you could sit down and walk me through every line of code, and you turned this in, yes, the game is not object-oriented. But the whole program is using object-oriented. It's actually a really good use of objects with collaborators and dumb classes here. Like, I thought this went really well. Even though that game is not object-oriented and there's like some really lazy-looking programming right here, I'm good with this. Like, this is a good solution. Now, granted, it's not blackjack. Blackjack's a little bit more complicated, right? You have to have rules like, I want another card. But what is, from the deck's perspective, what is a player hitting? Like, what is that doing from the deck when a player wants to hit? It's taking one card and moving it somewhere else. So maybe a hit could work in a similar way. It has a temporary dependency on a deck, and it takes it from there. Now let's go over here to our drawing. Now, this was the way that we chose to go. Do you all feel good about that decision in retrospect? I don't think it added anything, that taking 2 cards and putting it here. What it essentially did was this right here, using this method, which, how do I switch this to green? What? Pick the color, you dingus. Oh, this is the color. There we go. It's been a while since I've used a color picker. Oh, wow. Neon green is a bad idea. How about that? Let's do red. This right here is essentially the game class picking 2 cards and giving it to the player. So the responsibility of taking 2 cards would have been taking the responsibility away from the player. So that would mean that the player never has a temporary dependency on the deck. When we're describing our program in that way, we're saying the player never has a dependency on the deck, the game controls that. So the player's just given 2 cards. So we're removing that even more from the story. Like, imagine your player in a white padded room somewhere. When they are told to draw cards, they pretty much are just given 2 cards through a slot in the door. Whereas before, they were handed a deck and they were told to take 2 cards.
So would it not be better to avoid dependencies where possible?
The question was a great question. Would it be better to avoid dependencies if possible? I think people have been arguing over that for decades. In this case, it's kind of a wash of a decision. But that decision will come up many times in your career of we need to reduce dependencies. I can give you some advice right now that when you reduce dependencies, you make your program more future-proof. You make classes a little bit more ability to adapt to change. So when you have a class that has less dependencies, so like we have our player class, if we removed this dependency from the deck from the player class, we might be able to reuse the player class in multiple games. Because right now, draw from deck is hard-coded to take 2 cards from deck. Now, it doesn't have a hard dependency on the deck in that it creates a deck. It still is an external dependency, so it's still pretty flexible. But this just knows that it has to draw 2 cards. What if, though, if draw from deck was changed to draw from cards given, and instead of deck, we were just given a list of cards? If we were given a list of cards, that's moving the responsibility back to the game to say, hey, give me a list of 2 cards. Then we could just for loop over those 2 cards, and we could say self.add.
Well, for that matter, you just literally remove the draw from deck method
Yes.
and have the game controller draw from the deck, and then the player add to what was given.
Right, so the game controller would tell the player to add those cards. So that's essentially, so imagine we're back in our white padded room. Instead of getting a deck handed to us, which is what we coded, then we said we can remove that dependency on the deck to say we're just given 2 cards. Really at that point, what we're doing is that the player is now just given 1 card through the slot in the door, and they just take it and add it to their hand no matter how many times it was given to them. So we could remove draw from deck and put that logic down here. And now our player, honestly, our player class could be used in blackjack, poker, any card game, because they have a hand. They can add a card to that hand. They can add up all the value in that hand, basically 0 through 1,000,000, and they could compare. So by removing the draw from deck method completely and moving that logic into the game, our player is now very flexible and can take part in any kind of card game. So, to answer your question, would it be better to remove the dependency from the deck if you want to make your code more future-proof and flexible for the future? Yes. A concrete answer is yes. Is that the scope of our project right now, though? No, it is not. So the big question is, what's the better solution? The one that you understand better is the number one answer to that. There's many answers to that question. The one that you understand better is the number one answer to that question. But it also has to work. The one you understand better, that works, is the number one answer to that question. The second is, what fits in the scope that you were given? Does your boss say, make this ability, in the future we're going to add some stuff. So your brain cycles are going to say, I'm going to work a little bit harder to reduce external dependencies so that when we do get to that point, we'll be better off. Or your boss says, this is a one-off thing that a client just handed me a $100 bill for over lunch, so I only want you to spend 2 hours on it. So hard code the dependencies. In fact, I don't care how you do it, just make it work. That will never happen, by the way. Like, your boss will never take $100 over lunch and tell you to do something in 2 hours because they're making no money on it at that point. Maybe if you can do it in 10 minutes, but it all has to do with business requirements. Because honestly, like I've said, sometimes I like to run this class like a software development shop. And the best solution is the one that you understand, that works, that also fits the project scope. The project scope for this assignment has nothing to do with future-proofing. If you want to hard code in 2 draws for your initial draw, sure, that'll work, but it won't work for a hit. That will work for an initial draw, and a hit is 1 more draw. So that's on you as a designer. I think what was really highlighted well today was that design can take many forms. So there's not just one way to design something. But there are guidelines that we can have. That the only reason why this went so well today, I'm going to promise you this, is that I've done this for a very long time. Like, I don't consider myself any better or any smarter than any of you. I just got an earlier start. Like, I started doing this a couple of years before you did. And a couple being like, what, 8 or so? So what you're seeing is a result of a career of solving these problems. So I don't expect this to be second nature to you like it does for me. But what we're doing is we're moving the needle in that direction. Like, I'm all the way over here, you're over here. We just need to start pulling that needle this way so that you can confidently make these decisions that say, is this dependency a good dependency? Have I structured my classes the right way? Because you're not going to end the class over here, but you sure as hell can get hired if you're here. If you can talk if you can talk through your blackjack program intelligently with dependencies and object-oriented principles in a job interview, that will reflect very well on you. So, okay, we've just gone long now. I'll take any more questions you have, though. I'm not going to end it here. This is a big one. They definitely will. What's going to happen is you are going to design your program. Here's an exercise. I want all of you to do this. This includes anybody at home. How do I create a new thing? Or how do I close it? There we go. Yeah, blank. Ooh, I do like grid though. Can I make a shape? Can I just say square? Line. I don't. Vector fill? No. Okay, I can draw squares. That's no problem. I want all of you to do this. All of you are going to, and I think I did most of the work for you with Blackjack, is that I want you to, thanks JavaScript. Okay, so we're going to have to deal with this little wavelength thing here for a while. It just won't go away. I'm sorry for that. Using new software. What we're going to do is you're going to draw out every class in your program as a class relationship card. What that looks like, I can't do up arrows or left arrows, obviously. Up and left are weird for me. CRC card. I actually forget this. If you look up CRC cards, you'll see the layout. Where is it? Where is it? Where is it? Show me a freaking picture of it, man. Simple online CRC editor. Even better. New CRC card. Class name. What you're going to do is you're going to lay out every class that you want to put into your program. So it could be deck. Oh, goodness. We didn't describe any of these. Boundary, controller, or entity. I believe the card will be an entity object. This might be a bad idea. Wow, so if you make another one, oh, you add your responsibilities and collaborators right here. That's really neat. This actually might be really good. Don't worry about object types. Let's just say that we have a card. The card's responsibilities is to know its value. Or we say no value. Collaborator, does the card have any collaborators? Deck and player. Does the card directly collaborate with anybody? No. We're going to save that card. So the card is supposed to know its value. You can move that card over here. We want to make a new CRC card. We have a deck now, right? The responsibilities of the deck. Now that we've coded all of it, we know it. But what I want you to do for your program is I want you to try to plan this out. You're not going to get it right. It's fine. But I want you to kind of sketch out with these CRC cards what are the responsibilities. So the responsibility of this deck is to populate deck with cards. It's also going to shuffle cards. Shuffle cards. It's going to be able to draw a card, and it should be able to output display of cards. Does a deck have any immediate collaborators? Card. Correct. Notice that that's in all capitals. We save this card, and we can put this right next to it. So we have a deck Come on. Ah! I can't move it. Looks like I can edit it, though. Why can't I move it anymore? There we go. Okay, so I also have my player. Player's responsibilities. I want to have a hand of cards. I should be able to add a card to hand. I'm going to leave that next part open-ended for you. Like, how do you want to do that? Like, do you want to be able to take a deck and add it to it? I'll leave that open for you. Hand value is going to be add up value of all cards. Compare greater than to other deck, or to other player. Compare equal to other player. So collaborators, we have card, right? So we can say card through hand. This is the optional part, right? So I'm not going to put like a temporary dependency on the deck. But we also have temporary dependencies to other players. So we need to say player, and we say temp. Save the card. Oh, crap. I didn't realize it would do this. Delete card. Okay, so it wants us, it's going to link them. So we're going to say card and player. Why can't I save it? Oh, because we're on player. It won't let me add itself as a dependency. That's kind of a bug because you should be able to do that. Anyways, you don't have to use this program. The idea is that the name of, it's basically 3 columns, or 2 columns, 1 row. Name. Oh my God. Shut up. Okay. That's your CRC card. This is probably my best work. I'm a little giddy over this now. That's a great way to end class today, especially on a Thursday. Like, let that be your ray of optimism as you head into this awful weekend of homework. All right? Cool. I'm going to end the recording now.